As an architecture, engineering, and design firm, there are two sides to the work we do. The genuine side of building relationships and bettering communities, and the ingenuity side of solving problems and designing the future. It's when we combine our genuine approach with our design ingenuity that we're able to see the whole picture. The intricate details and the broader perspective. The contrast and the complements. The horizontal and the vertical. The people and the process. The two sides that make us whole. Gresham Smith, genuine ingenuity.
Good afternoon, everyone, and thank you for joining us for the third installment of the CX Energy Virtual Experience. These webinars are presented by the AABC Commissioning Group, as well as its sister organizations, the Associated Air Balance Council and the Energy Management Association. For those of you on the line who don't know me, I'm Sam Schwartz, and I'm a Member Engagement and Marketing Manager for ACG, AABC, and EMA. Since we were unable to have CX Energy in person this year, we're hoping to bring you as much of the commissioning, energy management, and testing related education as we can through a combination of these live webinars, as well as some additional pre-recorded sessions. I do just have a few quick notes before we get started. We encourage you to submit questions at any time using the Questions tab on the left-hand side of your screen. But while doing so, please make sure to submit questions to the questions box and not the general chat box. A few will be selected to answer at the end of the webinar, and the speaker will answer the rest via email afterward. Also, on the left-hand side of your screen, you will see the Resources tab where you can download a PDF of today's slides. There is also a Notes tab on the right-hand side of your screen where you can make notes in today's webinar, and they will be emailed to you automatically at the end of the presentation. If you're experiencing any technical problems during the webinar, please click on the Request Support button on the lower left side of the player. And then finally, in terms of continuing education credit, you will receive an email after the webinar with instructions on how to get your proof of attendance. We're going to be asking you to check into these sessions through the CX Energy app to help automate that process. Continuing the virtual experience today is Succeed When You Leave, Strategies for Ensuring Persistence of Savings on Energy Projects, with your speaker, Paul Raschilla of Acceptance Engineering. Just want to thank everyone again for joining us. And with that, Paul, I'm going to be handing it off to you.
Thank you very much, Sam. It's a pleasure to be here. I am Paul Raschilla, your instructor for today. We will engage in Succeed When You Leave, Strategies for Ensuring Persistence of Savings on Energy Projects. I am an energy management professional through the EMA, as well as a certified measurement and verification professional through the Association of Energy Engineers. Acceptance Engineering is a veteran-owned small business. Thank you for this opportunity. Our learning objectives for today. Recognize the industry-accepted standards and guidelines for measurement and verification, including the International Performance Measurements and Verification Protocol, also known as IPMVP, and ASHRAE Guideline 14-2014. We have provided some reference material under resources for you to have and keep. Also, as we're going along, if you do have any questions, please submit them for us. If we do not have time today to answer them, we will endeavor to get you the answers. We will also endeavor to understand the multi-step process for measurement and verification, including the various approaches, different options, establishing the implemented measures, baseline performance, and activities to verify projected improvements. Key thing is, if we want to see how much we improved, how much we saved, we need to figure out what can we and when can we measure it. Let's try to figure out how advancement and expansion in power monitoring, sub-metering, data analytics has advanced. What's different today than when M&V started coming out about 15 years ago? Understanding the enduring value created by training O&M staff. Our operations and maintenance staff is critical to keeping this persistent measure going. The ongoing commissioning effort, implementing CMMS and the FDD programs. So we'll go through how does that tie your maintenance into your computer and fault detection programs, if you have any, and developing serviceable documentation. Do we do all this work in-house? Do we get service contracts? So, let's begin. What is measurement and verification, M&V? M&V is the process of using measurement to reliably determine actual savings. So for us, we're looking at energy consumption and cost savings related to that. As you see on the right, we do have a diagram there. Energy use on the left axis, time across the bottom. It's basically broken up into a baseline period. So what was going on energy-wise during this time? And then we have a project, we make a change, something that will impact usage of energy. And then we continue to trend and monitor and see what's happening after that project was implemented. It's noted there as ECM installation, increased production, savings, avoided energy use. We'll go through the process on how we use M&V to figure this out. So M&V was created within an individual facility by an energy management, energy conservation, or energy efficiency project or program. So you might have a facility or a portfolio of buildings looking to save some energy. However, it has also been expanded lately to include reduction in atmospheric emissions. We're looking at indoor environmental quality, reductions in risks associated with your systems in place at a building site, or maybe even laboratory or other location, and increase in resiliency and reliability. It's critical in some facilities that we have that reliability, the redundancy, and it really comes back to what is the intent for your systems and where do we have leeway to save on energy. We'll use measurement and verification to try to identify those and capture them. M&V Sub-Metering Overview. So we all have meters at our home or office. We get a bill typically for utilities. Think of sub-meters, simply sensors that measure that flow of energy, regardless of what you have, whether it's gas, water, steam, electrical, in a little more detail than your typical utility meter. So modern meters are often capable of capturing greater detail, usually at 15-minute intervals. And when we're talking about sub-metering, it's not what's already installed from your utility. These are meters that we're installing inside the building to capture more detail on otherwise not metered or not monitored, like tenant spaces. So as we go through, we'll learn more about that. General sub-metering usage. In these first few slides, I'm really ensuring that we all have the same jargon as we're going through, because there is a lot of information. General sub-metering usage, operational improvements and energy savings. Big picture. You could also figure out tenant billing. If you have a 1 million square foot facility, but you have 1,000 tenants in it, how do you know who's using the energy? We also have to sub-meter sometimes for compliance and sustainability items. If you're pursuing a LEED certification for your building or have Energy Star portfolio manager requirements, or maybe even a contract for performance on energy savings, might have to put additional sub-metering during that contract period to verify the savings. We also use it for fault detection on equipment. Might have a piece of gear that's in a remote location and you really want to monitor it 24/7 or periodically to see how it's operating, to know when to do your predictive maintenance or to make adjustments to keep it within the efficiency range of operation. Some advanced technologies for measurement and verification. These are getting a lot of play lately as our computer systems are matching higher levels of BIM and Revit delivery for projects. We're getting more intelligent as far as the information we'll receive at project turnover. So with computer systems merging into energy management and information systems, it's really aiding efficiency by being online and a much more robust management system, and whether it's a BMS or any sort of connectivity that you could remote log in or web-based. The combination of using an EMIS with a monitored base commissioning process, MBCX, has been shown to reduce building energy waste up to 15%. That alone. The fact that you can identify it, monitor it, measure it, and have an alarm, a flag, or some way to know when a device is out of spec, you're out of range, you're not within the expected range of energy usage, so that you can make an impacting change to get back into the efficient range. But through the monitored base commissioning process, operators get to know their building systems continuously. So now you're learning about what's going on the off hours, on the nights, the weekends, what's happening when no one's there. We don't typically have 24/7 shifts, 7 days a week on holidays. So through this monitored base commissioning, if something goes wrong on the weekend, typically Friday night, 2 a.m., you have that transparency now. As we go on, we are also seeing an emergence, and we're seeing this more and more inside the residential home with smart technology, smart plugs, Internet of Things connectivity. Now, if you look at it from a building perspective, a campus perspective, a portfolio perspective, each one of these buildings can be connected using smart technologies to have even greater transparency on measurement and verification, whether it's on your HVAC systems, your lighting, security, all the way down to desktops and figuring out who's logged on when and how many desktops are in use. Electrical storage, if you have electric vehicles out front, understanding really, do we have enough? What's the demand? What's the load on the system? Do we have any CHP or other renewable energy and other sustainable energy sources on the grid, so that we could really figure out how much power am I getting into my location and where is it going once it's there, and what am I doing with it internally. So now, having said that, what are some benefits of measurement and verification? Why would we want to go to this level? For me, it's so that we can accurately assess energy savings for a project. If we understand what we're measuring and where our baseline is, we could actually capture those great energy saving measures that we've implemented. Allocate risk to the appropriate parties. Who's installing, who's furnishing, who's operating. We're really in it together to save energy. It's a team effort. However, we do have performance scope and schedule and contractual responsibilities. So understanding, yes, I paid a lot of money for that device to get installed onto my grid. However, is it actually functioning and performing as expected? What was the intent, and how am I verifying that? Reduce uncertainties to reasonable levels. This way, the project team understands this is what we're going to get, this is what we're going to measure, this is an acceptable project. Monitor actual equipment performance. Sometimes, that shiny new fan looks like it's great. However, that older beat up one is running better, it's balanced better. It's sometimes just a manufacturing anomaly, but we have seen through measurement and verification and very tight testing, adjusting, and balancing during commissioning and turnover, that some new devices and equipment come with manufacturing defects that have to get corrected prior to final acceptance. Find additional savings during typical operation. If we're doing measurement and verification within our acceptable parameters, we can actually drill down and say, all right, those non-normal modes of operation, what's going on there? There might be other opportunities for saving money, either through energy use or from predictive maintenance that we didn't realize. Verified cost savings guarantee is met. We do have a lot of performance contracts in place. So how do you know if you're paying based on a percentage of savings? We really should have that savings verified, auditable, and have that transparency so that the costs are correct and aligned with the contract terms. And baseline for future adjustments. If I know what my building equipment, my systems are doing now for the level of O&M that I have in place, then I can make changes that are feasible, impactful, and really drive down energy usage as needed. Some reasons to implement measurement and verification. Might be part of a risk management strategy for energy managers and energy service performance contractors. We use it to help verify and or accept that performance. Helps us to mitigate the financial risks, interest rates, energy prices, construction costs, M&V cost delays. Perfect example, you have a budget, first year of operation energy. However, the system was not operating efficiently. Maybe it didn't get commissioned. We didn't get a final balancing, or the end users moved in and used the space differently than intended. And you end up using 300% more energy. And that cost, where do you get the money for it? So really using M&V to highlight that and mitigate those financial risks. Operational risks, operating hours, load, weather, end user participation. Understanding the intent, different sequences of operations, the integrated and interconnected effects these systems have on themselves and the building as a whole, and look at it. Where's my energy balance in this building? And performance risks, equipment performance. We paid for it. It's a shakeout period. We don't have final loading in the building. Am I running in an intermittent or a partial acceptance scenario? Do I really understand what is left to accept this? Have I been able to do a performance final verification or demonstration given the load and conditions? Understanding when should warranty really start? Have I proven out all the intent? So using M&V to help mitigate these risk factors is helpful. Having said that, some of the typical parties using M&V to do just that. Energy performance contractors, right? EPCs, and the customers. They're holding each other accountable. Facility energy managers to highlight energy variances. New building designers, if we're seeking sustainability or efficiency certifications, or maybe some municipality requirement to demonstrate performance against a guideline. Both private and public energy users, they're doing their own retrofits and they want to document energy savings. Maybe your stakeholders need to know. If it's a small school system, it's goodwill and you want to publish that and actually teach your users, your stakeholders, how you're using your budget more efficiently to save energy throughout the year. Water efficiency project developers, or water efficiency on your own grounds. Emission reductions. Municipalities and other government agencies, many of them are requiring this at a level for government buildings. And portfolio property managers. How do you benchmark one building against the other in a portfolio? And how do you capture those savings and pass them on to the tenant in a different way? So we do have some key measurement and verification codes, standards, and guidelines we follow. International Performance Measurement and Verification Protocol, IPMV, P, that's pretty much the main one that lays out many of the items that we will go through during this presentation. ASHRAE Guideline 14, 2014, measurement of energy demand and water savings. And these guidelines really work together. One will be a guide, the other one will give you the how-to and a model for implementing and capturing and recording this data and setting up the project. M&V guidelines in general, measurement and verification for federal energy projects. Two of these resources are in your resource tab for review later on. Greenhouse gas protocol for project accounting, and the ASHRAE Standard 211 2018 standard for commercial building energy audits. As we go through setting up a measurement and verification plan and implementation, we are really pulling from all of these different guides and creating a manageable way to go through this process that's both reliable and repeatable. I thought it was important to have these next couple of slides in here to ensure the vernacular and some basic units of measure conversions. I'm not going to spend a lot of time on them, but they're here. Key thing is using consistent units throughout calculations. And some basic acronyms, CX, commissioning, since we each come from different perspectives, and when it comes to measurement or verification, our experience and whether you had hands-on, what level administratively, maybe you were a contractor, you have furnished and installed the retrofit side. However, a lot of times we're each doing a piece of this measurement or verification plan, whether it's the budgeting, the planning, the implementation, coming back and doing the third-party verification as a commissioning agent, or running the whole project. Either way, this is a way ACG and the EMA believe that we can all speak the same language. At least we know and where we fit in the realm of this whole planning process and implementation. Commissioning, different levels of commissioning. As we go through, we'll get into more details on energy conservation measures and energy efficiency measures. Energy use index is very important for portfolio managers using Energy Star. What's a FIM? Sometimes it's not a typical word or acronym used, but facility improvement measure, and you'll learn more about that. If you do level of commissioning for acceptance, we talk about functional performance tests. Indoor environmental quality, we used to call it indoor air quality, and now it's generated into capturing the entire of the environmental. Leadership in energy and environmental design. Many of us in the energy sector are very familiar with LEED and other guidelines we use where it comes to energy certifications and playbooks. M&V, measurement and verification. MBCX, monitoring based commissioning. Ongoing commissioning, it's changed over time. However, it's still at existing building commissioning or / retro commissioning. And now we're moving that to existing building equipment system commissioning for systems that had never been commissioned, and ongoing commissioning and recommissioning and return on investment, some of the basics for us. The M&V process. So how do we get started? Determination of baseline performance period. What's that period we saw early on where we're in normal automatic operation and this is how much energy we're using? We have to decide on what that period of time is. Estimated savings through an energy audit. We have additional resources for ASHRAE energy audit implementation. Development of an M&V plan. Now that I'm collecting this information, I'm trying to figure out, okay, now let's get a measurement and verification plan in place and figure out who's doing what, when, and where. Let's turn this into a project. Compilation of a post-implementation report. Verifying performance. I have data, I've collected it, I'm going to analyze it. I'm writing that report based on everything I've done. And what additional ongoing M&V activities should I be doing to maintain that persistence? Do I have regularly scheduled O&M activities related to M&V on a daily, weekly, monthly, quarterly basis, annually basis? Establishing that baseline performance. Understand what's already metered for the subject area. What bills do we get in from a utility perspective? Where are my meters? What type of utilities are they on? And how often do I get a bill? Let's collect and analyze those utility bills. I typically like drawing a box around my building or space and figuring out, these are the meters, this is where they're coming in, and this is how often I get them. And also figure out who's paying the bills, because accounting usually has a better understanding of all the different meters and bills that come in and out. For existing facilities, we try to get a minimum of 3 years, so we could actually hone in on that baseline period. Create an energy balance. Identify baseline energy usage by fuel source. If you have dual fuel, tri-fuel, different energy equipment using various fuels, break them down. Define an energy balance for each energy source. Subdivide the largest energy consuming systems. We have a very simple energy balance shown there in the graph. It's an all-electric building, just the HVAC detail. As you can see, the red, 49% of all electric in our HVAC equipment and systems is used by the chillers, with 9% being used by our water pumps. So as you go through, we're getting a better understanding of what's measurable, what's using the energy in our building, and then we create this energy balance for management purposes. And establish a baseline of operation. And that baseline of operation is going to be based on what could we measure across that period for demand and consumption. This may be for the whole facility or just a specific area or specific systems, depending on how the data is gathered and what's your priority. An ECM or an EEM versus a FIM. Energy conservation measures, ECMs, and energy efficiency measures are typically interchangeable. There are some nuances, however, really drill down on what you're trying to accomplish with these measures. They're basically a project conducted, initiative or technology implemented that reduces the energy in a facility. Measure can affect a variety of resources, mainly water, electric, gas. Use residential, commercial, industrial facilities. Difference between those and a FIM. FIM is a facility improvement measure, FIM. Project or initiative to improve building and system performance or reliability, resiliency, reduce O&M costs, improve indoor environmental quality. Measure may or may not reduce energy consumption and related costs. However, it might be critical to maintain compliance. Now, as you go through this, I like to highlight the fact our buildings, our codes, our guidelines, it's not just energy anymore. We're looking at energy and compliance. It's only feasible if we could do it and still maintain compliance for our authorities having jurisdiction. Understanding you might need a FIM to capture more energy. However, that FIM to maintain compliance, you will you will get to a point where you have limits on how much energy you can reduce. You know, you just might have to continuously run that one fan you would love to turn off, however, you need it for compliance. Understanding your building, the compliance side and the energy side is key. In evaluating energy opportunities, we typically go through a budget process, and it's key to understand simple payback, return on investment. Why are we doing this? We're doing these to save energy. How much energy over how much time? What's my payback? If it's going to cost me X, when am I getting X back? When do I start making money off that energy saving measure? So, established financial analysis method might be a simple payback. I'm going to fund items that are between 1 and 3 years. This is how much that measure is going to cost. This is how much savings per year. Very simple method. Or return on investment. Annual return on investment, ROI. Return savings from investment annually divided by the cost of the investment. And as we get into more detail, present worth analysis and a life cycle cost analysis. In your resources, we have additional information that breaks out problems and setups for all these. Payback period versus present worth. It's good to understand from a financial standpoint. A lot of times the C-suite deciding which one of these projects are going to get funded want to understand what's the financial value of it. So payback period, simple to use and understand, easy to compute. Preference to liquidity, it deals with some risk. It really ignores the time value of money. This is how much I'm putting in, I'm getting it back over 3 years with the savings, 4 years, 5 years. Not all cash flows are covered. It's quick, simple, easy to do. It ignores profitability. Net present worth, or the net present value side of it. It's more flexible and meaningful, especially if you're using this assessment to set budgets and get funding, financial funding to implement the projects. Today's dollar value for a potential investment, you might use this more if you're evaluating different type of equipment, different type of chillers or boilers, to really figure out which one should I do. They look good at first cost, however, now you're starting to add in the time value of money, which it's a little more difficult to calculate. You might get some help, but there are plenty of tools out there and resources for you. Present worth analysis, simple setup equation that we use, present worth, future value divided by quantity 1 plus I raised to the n. I is your interest, n is the term, typically in years. But make sure your interest and your years match. Life cycle cost, LCC. I like using life cycle cost because coming from the operational side of the fence, first costs are good to get the equipment and systems put in. However, understanding if I'm going to run this system for 10, 20, 30 years, how much is it going to cost me each year? This is really where we start taking into consideration what level of operator do I need, how much maintenance, what's the cost? If it breaks, how much will it cost to repair or replace? And life cycle cost takes that into consideration. It's very useful in comparing alternate systems. Might have competing technologies, but when you put it on paper and take in the operation and maintenance and repair perspective into account, you might be surprised. That first cost where you're saving a lot of money actually ends up costing you more over a 10-year or 20-year period. Understand and be consistent. That's the key thing. And the basic life cycle cost calculation, where I equals the present value of investment cost plus that replacement cost. Present value, the residual value. If I decommission this, am I getting anything from it? What's the value there? E, the energy cost, once again in present value. W with the water cost. And O and M and R, understanding what's expected from an operation, maintenance, might be a special piece of equipment that you have to get under service contract and some other contract cost. Basically, there's additional information in there. Maybe what's the cost of not performing on that service contract? What if I don't meet my savings? What if I have to get bonding or other third parties in there? Really understanding what our contracts have in place is critical, because that's where a lot of our exposure is from a liability and cost standpoint. Other factors when evaluating potential ECMs and EEMs: regulatory or code compliance, what are my limitations? Life safety issues, what about that integrated, interconnected life safety, fire alarm, fire protection system? Employee comfort, IEQ, increased productivity, shift work, operational adjustments. Can I shut down a part of the building on nights and weekends, holidays? Different changes to technology. What happens if the equipment I just put in or the sensors become obsolete? How much will it cost to replace that? We don't know, but we can put in a flexible backbone that makes it lower risk for those type of changes. What if I have a different tenant and they want to use the space differently? How's that impact us? And O&M service strategy in-house, outsource, manage third party, understanding what will I do once the space is accepted can really impact our cost and our level of energy efficiency. We like to establish measurement and verification budget for consideration. As we go through that, more rigorous the M&V, so the more I'm measuring, the more I'm verifying, the more expensive it will be. Some of the factors are, what level of detail and effort do I want during this verification period? What's my sample size? How many different points? What's good enough? What's my intent? We all love more data. However, more data costs more money. What are my limitations on duration and accuracy of existing meters? What do I really need to augment? Where do I have to submeter? Do I have the power to submeter effectively? Do I have the resources operationally to ensure that these submeters are in effect and functioning? Or do I have to buy everything and install new? Number and complexity of variables in the analysis. Simpler is better for me. Really identify whether it's runtime. Understand if you could get a lot of information with a little data, you're better off, because you will have to measure and verify against this baseline later on. What's the level of engineering required? Is this something you could do in-house, or do you have to hire a third party? Do you have resources you could use through your professional organizations like the EMA? What's the existing data already collected? You might have a BMS or BAS system or an energy management system in place that a different department's using and tracking. Ask around. Contract term. Is there a specific contract in place that I need to meter during? And what's the level of accuracy needed? And that really goes back to what type of calculations I plan on doing and a level of analysis. I like using M&V budget approximations. The M&V effort should be scaled to the value of the project or group of activities. Do the appropriate level of measurement or verification based on the project or energy capture you're targeting. And based on our experience, we're seeing between 2 to 5% of the typical annual project estimated cost savings. And just very simple graphical representation on the right. Before the project, you have maintenance cost and energy cost. After the project, you have the maintenance cost, the energy cost, and some captured energy savings. So that 2 to 5% would come out of that green energy savings piece of the pie. That's your target. Outline for project-specific measurement and verification plans. Develop the details for a baseline condition and data. Document all the assumptions and sources of data. What will be verified? Who will conduct the M&V activities? This is really your playbook. This is the game we're doing. It's called measurement and verification. Understand all your players and the rules of engagement. What details for engineering analysis are performed? Come up with your standard forms, spreadsheets, have that part of your plan. Same periodicity for reporting, how you calculate your energy savings. I like using a block diagram to indicate locations for all the required meters and the different monitoring devices we'll have in place. This way I could go and do rounds and verify that they're still installed and operating properly through the periods. Utility rates, sometimes these are tricky. You really have to drill down and may have to talk to your utility provider to have a better understanding of the rates being used. And understanding any tariffs or other utility rate points you should be aware of. There is some risk there. Specific information regarding the method and the frequency for data collection, 5 minutes, 10 minutes, 15 minutes, half hour. Detailing operations cost, savings claimed. So once I do have the savings from energy for a specific system or building, what am I doing with that? Can I funnel that back into an O&M repair account to fund additional EEMs? Establish the M&V period. 1 year typically for new construction projects. However, you might want to go 2 seasons, so maybe 18 months if it's a chiller project, or if it's only cooling or only heating, you might want to capture 2 seasons. And what's the format you're going to use? M&V approaches. As you can see from the house here, we have retrofit, isolation, options A and B on the left, versus whole facility method, option C and D on the right. Key thing is the meter is on the inside of the building, option A and B. It's on the outside of the building, option C and D. So whole facility, metering the whole. Retrofit isolation approach looks only at affected systems typically. Equipment for energy savings, independent of balance of the facility. Whole facility approach considers total energy use of the entire facility and typically ignoring specific system or equipment performance. This is the energy I'm getting on site, and this is what's going on. Various M&V approaches, and these are laid out in more detail in our reference material. Option A, retrofit isolation approach, stipulated and short-term measured factors. Option B, retrofit isolation approach, continuously measured and stipulated factors. And we'll have some examples coming up. Option C, a whole facility approach, utility billing, meter, sub-meter, regression analysis. Maybe you just have the 1 meter and we don't have any additional money for other sub-meters. It's going to be a high level, broad stroke, and maybe that's all the information we need. Really comes down to what type of project you're looking at and what's available to you. And option D, calibrated computer simulation. Typically, if the building hasn't been built, this usually ends up being our only recourse. Computer simulation model calibrated with whole building, or end use meter data once the building goes live. We fine tune that model through different iterations as we get closer to final design and as the construction is nearing completion. And many of these items each one of these items that we're going over through the presentation, there are various specific consultants out there to help, to support. A lot of these are specialties. It's good to understand at a high level the intent However, there will be a time where you need a specialist who does this for a living. Think about that as you're setting up your M&V plan. Option A, retrofit isolation, a little more detail. Actual savings determined from short-term data collection, engineering calculations, and stipulated factors. But we could pretty much do this on a spreadsheet. I got this great idea. I want to save some money. Let's do this. How much will it save? Do I meet my return on investment 3-year, 4-year, 5-year, and under? Typically, if it's 1 year or less, it's considered an operation maintenance, low cost, no cost, corrective action, and it should actually be part of our ongoing maintenance and repair. Post-installation energy use, equipment performance, usage not continuously measured. Intent is to really verify, all right, this is how much I was using, I made this change, implemented this retrofit, now I'm using this much energy. Level of accuracy really depends on the assumptions and what measurements are taken. How granular did you get? That's a good broad measurement. Most of us are familiar with lighting upgrades. Now, this is an option A example. Keep number of fixtures, how much power is consumed per the existing fixture, what's our baseline, right? That's already installed. I'm going to change this out with a new fixture, the retrofit project. So how much is the new fixture going to consume? How many operating hours using that for either? We're going to keep them the same, apples to apples. And the energy savings, difference between power consumed by the existing versus the new, multiplied by the operating hours. Total cost is the cost of the fixtures, furnish and install, with the labor to swap them out. M&V option B, a retrofit isolation, similar to option A, but uses periodic or continuous metering during that post-implementation. So now that I implemented the project, I'm monitoring, I'm trending. It's really intended for retrofits with performance factors. We're measuring at that equipment or system level to verify that we met intent on the long-term performance. Continuous monitoring information can be used to improve and optimize the system. Hey, this is what I intended. This is where it should be running, energy efficiency wise in spring versus summer versus fall. Do I have some seasonality in there I need to improve on? It really helps you get through that whole performance cycle. And it provides the greatest accuracy in the calculation of savings because you're monitoring continuously. That's real data, and you can adjust that accordingly for degree days and environmental factors. Option B, typical example for a variable frequency drive, VFD installation. Measured energy consumed by the motor during constant speed operation. Measured energy consumed by the motor post retrofit during an equal time period. Now the key thing is we're putting that variable frequency drive on there that we can adjust based on demand. Really understanding your load conditions and your system conditions is key. However, you could get some great energy savings. Difference between the metered energy consumed pre-retrofit and post-retrofit, and the implementation cost, total cost of VFD, the labor to install, and any associated meter data logging, testing, adjusting, and balancing. You want to save the energy without disrupting the entire system during these examples. M&V option C, whole facility. Savings are based on actual energy consumption, usually at your utility meters or regression modeling. Evaluation based on facility level meter data, billing comparison. Generally, the overall level of savings must be at least 10% of the total meter usage for the method to be effective. You want to be able to capture that. Analyses usually consider changes in weather, occupancy, loads, operations, adjust baseline accordingly. Might have a system that you never had an occupancy schedule, and then you realized, you know what, we could put one of those in for nights and weekends or setback. This option will verify total performance of all the implemented measures, including interactions. We're capturing at the whole facility level so that we're not sub-metering down to each individual ECM. So it's really good for overall big picture approach, if that's all that you have. An example of that is a gas boiler installation. Gas consumption by the existing boiler during baseline period based on monthly utility bills. Gas consumption of the new high efficiency boiler during the retrofit period. Energy savings. Use a regression model with monthly heating degree days to establish baseline model and to normalize post retrofit. We want to make sure that we're normalized for the weather. And implementation costs. Cost of the new boiler, associated piping, electrical, the flue work, along with all installation labor and any sub-metering if applicable. Really big picture samples for you to have a better understanding of the different types of projects that may fall under these various options. And then the option D, whole facility. Option D is especially useful where baseline does not exist. So new construction, major building modification, or the savings aren't easily measured. Calibrated computer simulation model. These are great for our new construction projects. This is the percentage of energy I plan to save against my ASHRAE guideline or other energy guideline requirements. And a lot of times we go in, this is great, and we fine tune it during construction as submittals get approved. And as we're going through commissioning and testing, we feed that information back to the modeler. Those iterations get adjusted, and we get a model that's closer to what's actually installed and built. So we use that as our baseline. Long-term whole building energy use data, as well as system-level performance measurements, may be used to calibrate the simulations, and that's where we're going through our first 6 to 18 months of operation. An example of that, measures include glazing replacement, new roof, increased insulation, major upgrade HVAC systems. So we're going to use that computer simulation model to figure out this is our project, this is what we're changing, this is how much we plan on saving from an energy perspective. And then we edit that model based on what we tested, the information that we gathered, and we run it. And the implementation is basically the project. So great for big picture retrofits. Once I go through the project, I get to a point where I have my M&V post-implementation report outline. Very simply, this is my end of project report. So project description, installation verification, what measures were implemented, really want to have that in a little more detail. Changes, as-built conditions, energy impacts, commissioning results, performance verification, and the validation. That's the key thing. Go back to why we started the project and make sure your report has that in it. For persistent ongoing M&V related activities, local reporting, how often do I have to tell my municipality? Do I have any funding or contract requirements? Do I have quarterly reports I have to put in? Am I using monitoring based commissioning? How does this tie into my maintenance management plan? How often do I train my O&M staff? Do I recommission periodically? Am I adjusting budgets based on the energy usage data? Communicate for buy-in. Really need to get your senior management, your facilities O&M staff, and your employees / occupants and users community involved. Explain what you're doing, get the buy-in at the appropriate level, and understand who has which information that feeds in. Coordinate with the outside stakeholders. Understand that your contractors and subcontractors, yes, there's a contract. However, we're all on the same team. Which outside consultants do you need for different levels of projects? And do you have to bring in your utility representatives? Do you have to talk to them and figure out what are your limitations? Talk to your equipment vendors. What are your new technologies? What's available to you? It's good to do research. It's better to get knowledge based on your facility from those persons who have been working on site, and then bring in a few that haven't and get some different perspectives. Might find something very interesting. But overall, have that energy management project team in place. Understand your key players and talk throughout the project. And coordinate with your internal departments. Now that you have the project in place, as you're going through it, give regular updates on that energy management project team internally. Senior management, keep reporting in. Facilities management, O&M staff, let them know what changes are happening and what's expected of them, when training will happen. If you're going through a measurement verification period, ask them to please leave that in that hands-off condition and automatic and let you know if there's any problems. What's the reporting protocol? Same thing with the end users and the occupants. Train them on that. And add that value. Facilities and O&M staff, employees, occupants, tenants. Change the behavior best you can and keep it persistent. Tie it into your computerized maintenance management system, fault detection, and keep on trucking. M&V works. What you do with it works better for you. So I am Paul Raschilla. This has been an Energy Management Association presentation. Bob Knodler helped me with this presentation. Thanks, Bob. I believe we have some questions, so I'll turn it back on over to Sam.
Thank you, Paul.
You're
Yes,
welcome.
we do have a decent amount of questions, so let me get started and see how many we can cover. The first one is there any data showing energy savings associated with increased OA to achieve LEED credit for 30% excess OA?
Thank you very much for that. So is there any data showing energy savings associated with increased door air to achieve LEED credit? I could look into that for you. Not off the top of my head. However, there is we've had a lot of good resources lately.
Okay, the next person has a question about the pie chart on slide 15 that showed all electric building energy usage by equipment. They said that chiller, CHWPs, HWPs were shown, but not hot water producing equipment. And
Correct.
they're asking solar or geothermal heat.
That's a great question. This pie chart was only for this HVAC detail. That was solar only. Electric water heater was not captured as part of this project. Just had the hot water pump, and because we looked at it from the HVAC side on the electric building load. But some of the miscellaneous loads did pick it up. It didn't have a high component. It was solar though.
Okay, and the next question is baseline period typically a 1-year period prior to the retro commissioning implementation? Do you typically do weather normalization afterward?
Good question. Typically, we're looking at, we like that 3 years, I'll keep it on the slide, that 3 years for existing facilities, because we're seeking a nice 18-month period in there where we have good data. And out of that 18 months, we're drilling down to find a good 12-month baseline. So we're using a 12-month out of quality data. And we typically do weather normalize
Okay, the next one is to determine the breakdown energy consumption. Do you perform actual measurements at each equipment or have energy modeling done?
It depends. So how much money do we have? How much time do we have? I like doing a equipment and system level. So I'm capturing actual equipment, full load amps, and usage during my commissioning, bringing that online. But from a system perspective, I like verifying system performance against my sequence of operations. Hopefully that answers your question.
What is your process for calibrating energy models? Do you use historical weather data to calibrate? And if so, do you import weather data into energy model or externally somehow?
I leave that up to typically I leave that up to the modeler. We import based on where we're at from historical weather data to ensure our baseline period is normalized. And then we're using our weather data for actual and ramping up our measurement data. So we're getting the actual data and normalizing for weather at that point. Those iterations, the more useful actual information you could bring from your M&V effort to the modeler, the tighter those iterations get and the more appropriate the model is. But it also comes down to money. That's key. How many iterations did you buy with the modeler? How often? That's a great question to ask up front.
Next question is, does your firm install sensors and devices to measure energy usage and performance of equipment? Or do you utilize existing building automation systems and utility sensors? Can you recommend energy modeling and analyst software?
Great question. What we like to do is install independent data monitoring equipment and devices during the commissioning of our BMS, of our building management or energy management system initially. We're using our independent data loggers to verify that the building management system and its devices are operating properly and calibrated and trending. And then we like to leave some of those independent data loggers in place as a Q&A check, third party. Then we use the calibrated, commissioned building management system during the M&V process. As far as recommendations go, not at this time. We do have a lot of resources available through the EMA and our vendors, but I prefer to stay away from that at this point. Thank you. There's so many systems out there.
What does the basic M&V system for an office building cost dollars per square foot? What are the follow-up annual services costs to the owner to maintain the M&V system?
Good question. I have found that a lot of office buildings have a BMS installed. However, tweaking it and overlaying your M&V plan on top of that and getting some useful data usually does not cost more money if it's set up properly to begin with. Verifying what your meters are doing against what metrics do you want to manage against? That's upfront. I'm finding a lot of the scope and schedule and fees it can capture what you need to do with an M&V or monitored based commissioning system. However, it has to be laid up that way initially. If you have an existing BMS system, I would look at what its capabilities are before adding additional devices onto it. Typical cost, I go back to that 2 to 5%. How much energy do you plan on saving every year? And that drives how much more money you should spend or could spend on the M&V. And a lot of times that money is better put into replacing out-of-calibrated devices that are already included in your BMS system, and that's really your maintenance and repair. So we really have to understand what's installed, what information you're trying to get out of it, and use that 2 to 5% budget on, if you plan on saving 20% energy every year, 2 to 5% of that 20%.
Okay, thank you. The next question is, can you discuss the difference between incremental and average utility rates and talk about how this affects your energy savings calculations?
That's a little more complex for this level of presentation. Prefer not to get into utility rates at this time. However, we will issue something to the attendees.
Who normally installs any meters that are needed for M&V?
Typically, it depends on who's already on site. Many facilities have a service contract with a level of controls in place. If not the controls group you're using, a lot of times the electrical contractor on site or your in-house facilities technician.
Okay, the next question is, how do you take into account where occupants operate the facility in a fashion that counters the energy saving measures you put in place? And they put in an example, like a shop area where they continually open the overhead doors regardless of ambient weather conditions.
Wow, that's a very good one. We deal with that a lot. Unfortunately, how persons use a space is a touchy subject. It comes back to communication, understanding, and a lot of times maybe even challenging them. Department against department, there is a lot of pride in the work area. Really bringing them in and finding out, who do you need to talk to? Who do you need to win over? What is the barrier? Why is it a self-fulfilling prophecy that you ask them to do this to save energy, however they continue? Maybe there's something that both parties don't understand. Why is that overhead door always open? It really just comes down to communication and a lot more legwork on the front end, a lot more in the preparation and programming. You have to drill down. You have a lot of human factors coming into play at that point. How does this change impact them, and how do you turn it into a benefit that they could get on board with?
Okay, we have time for about 2 more questions.
Okay.
The next one is there any data available that quantifies the increased energy consumption cost for heating associated with LED lighting upgrades?
It's a good question. Off the top of my head, I'll say no. However, I will look into that.
Okay, and one more for you. Are there written qualification recommendations to share for hiring qualified commissioning professionals?
Yes. The ACG and the EMA do a good job with that. I know we have that information in our CXA and EMP information booklets. We could get that information along with some sample RFP documents.
Okay, thank you, Paul. That was the last question, actually.
All right. Well, thank you, everybody. I'm glad to be here. It was a pleasure, and look forward to sending you some additional information based on those questions we received. Have a great day.
Great.
Thank you, Sam.
And I just want to close things out by thanking Paul once again and everyone who joined us, including our members across all 3 organizations. Please keep an eye out for an email regarding information about your learning units from the CX Energy app. While in the app, we're also asking all participants to please evaluate this presentation And we also hope to see you again next week for the next webinar in the series titled Children's Hospital of Atlanta Case Study, Highly Effective Commissioning, taking place May 14th, 2 p.m., this same time next week. Have a great week, everyone.